Hi and welcome back. By the end of this video, you should be able to describe what's meant by an isotope. You should then be able to describe the key points of the mass spectrometer. And finally, you should be able to analyse a mass spectrum. This work sounds a bit tricky, but you'll find it's much easier than you might think. In the last video, we learned how to use atomic number and mass number to work out the numbers of protons, neutrons and electrons for atoms and ions. I said that you'd need to download and print out the datasheet for your exam board from one of the links below the video. Now, one thing that you'll notice is that the mass numbers in your periodic table are decimals. So the mass number for lithium is not 7, it's actually 6.9, and that's due to the presence of isotopes. Isotopes are atoms of the same element with different numbers of neutrons and different masses. That's a key definition, and you could be asked it in your exam, so you need to learn it exactly as it's written here. This shows the two isotopes of copper. You can see that each isotope has 29 protons, but the number of neutrons varies. This isotope has 34 neutrons, but this isotope has 36 neutrons. Now, one key idea that you need to get is abundance. Abundance tells us how common each isotope is. Around 69% of copper atoms are this isotope, whereas around 31% of copper atoms are this one. So the question is, how do we actually work out the mass number and abundance for isotopes? To do this, we use a machine called a mass spectrometer, and you could be asked that in your exam. If you're following the AQA specification, then you're meant to know the details of how the mass spectrometer works. This is called a time-of-flight mass spectrometer. There are other designs of mass spectrometer, but this is the one specifically mentioned in the AQA specification. In the first stage, we take a sample of the element that we're interested in. This contains all of the different isotopes for that element. We place this in the sample chamber. This then passes through a process called electrospray ionization. The key point about this stage is that it converts all the atoms of the element to positive ions. The positive ions then pass into an electric field. This causes the ions to accelerate, giving them kinetic energy. The key fact that you have to learn is that when the ions pass through the electric field, they all have the same kinetic energy. The ions now drift down the chamber at different speeds. Lighter ions move faster than heavier ions. When the ions reach the end of the chamber, they're detected. The time it takes for an ion to make its way down the drift chamber is used by the machine to work out the mass of the ion. The machine also tells us the percentage abundance of each isotope. Coming up, we're going to see how to interpret a mass spectrum. This is a very common exam question, but it's quite straightforward. Okay, so in this section we're going to look at how to interpret a mass spectrum. I'm showing you here the mass spectrum for the element copper. The first thing to notice is that the spectrum has got two peaks. That tells us that copper has two main isotopes. The y-axis shows us the relative abundance for the isotopes. Usually these abundances are also given at the top of each peak, like this. On the x-axis we've got the MZ ratio. This is the ratio of the mass of each ion to its charge. This looks a bit tricky, but it's not really. Remember, at the start of the mass spectrometer, we generated positive ions. The problem is that we can get ions with a single positive charge, a double positive charge, or even greater. The mass spectrometer compensates for this by giving us the mass to charge MZ ratio. Please do not worry about this. As far as we're concerned, we can simply think of this as the mass of each isotope. Here's a mass spectrum for you to interpret. This is for the element magnesium. I'd like you to work out how many magnesium isotopes are shown. Then I'd like you to work out the masses and abundances of each isotope. You can pause the video now. You can see that we have 3 peaks, which means that we have 3 isotopes. The first isotope has a mass of 24 and an abundance of 79%. The second isotope has a mass of 25 and an abundance of 10%. And the third isotope has a mass of 26 and an abundance of 11%. I'm going to give you one more mass spectrum to interpret. This is the mass spectrum for the element lead. Again, I'd like you to use the spectrum to work out how many lead isotopes are shown. Then I'd like you to determine the masses and abundances of each isotope. You should pause the video now. You can see that we have 4 peaks on the mass spectrum, so we've got 4 isotopes of lead. This isotope has a mass of 204 and an abundance of 1.4%. This isotope has a mass of 206 and an abundance of 24.1%. This isotope has a mass of 207 and an abundance of 22.1%. And finally, this isotope has a mass of 208 and an abundance of 52.4%. Okay, so hopefully now you should be able to describe what's meant by an isotope. You should then be able to describe the key points of the mass spectrometer. And finally, you should be able to analyse a mass spectrum.